This is problem 15 on the Manipulating Vectors with Trigonometry worksheet. This problem involves magnetic fields. We have two wires piercing the XY plane, parallel wires. One produces a clockwise magnetic field that has a magnitude of 300 millitesla at this point, and one has a counterclockwise field of 500 millitesla at the point in question. What is the magnitude and direction of the magnetic field at the point 0, 1 centimeter? First thing we have to do is to get the directions of the field. This is non-trivial. At the point 1, 0. What are the directions at that point? Well, let's find the point first. And get this right. 0, 1 centimeter is right here, right across from this wire. And 2 centimeters down, 1 centimeter over from that wire. The field from this wire is clockwise, like that. Let's draw it. The field from this wire is counterclockwise. Let's draw that. We don't care about the field anywhere except right here. What's the direction of the field from this wire right here? And what's the direction of the field from this wire right here? They form circles around the wire, so the magnetic field direction is always tangent to those circles. And you can make the circle any size you want. So here are the magnetic fields. This one's straight down, and this one's up and to the left. And it's easier to see if you draw the magnetic field circle through the point, like this. So when it comes around, that's straight down. And when this one comes around, it's like that. The magnetic field is tangent to the circle. Now we got to do a little bit of geometry to get this angle. What's the direction of this 300 millitesla magnetic field vector? So to start, put a dashed line from the wire to the point where you're measuring the field, and that's a right angle, of course, because that's a radius and that's a tangent. So let's call this angle theta from the horizontal. And we can calculate this angle because the opposite side is 2 centimeters. The adjacent side is 1 centimeter. Tangent of theta is 2 centimeters divided by 1 centimeter. And we can get the angle by taking the arctangent. The arctangent of 2 is 63.4. So the theta in this diagram is 63.4. We want this one. So what we do, the whole line is 180. We subtract 90 degrees for this angle, 63.4 for this angle, and we get this angle, 26.6. We can put it on the diagram. Now we can get the components of the 300 millitesla magnetic field. The horizontal, it's back, negative. So 300 millitesla cosine 26.6, that's minus 268 millitesla. And we want the sine for this one, 300 sine 26.6, that's up. And that's 134 millitesla. So now finally, we can really clean up this diagram. Get rid of all the stuff except the components. There they are. Now it's easy. 500 minus 134 is 366, and it's down. And in the horizontal direction, it's trivial because there's only one component. It's 268 that way. 366 millitesla down, 268 millitesla that way, and now we can just do some Pythagorean theorem and arctangent to get the net magnetic field at that point. So here's the Pythagorean theorem, 454 millitesla. We can put it on the diagram. We want to know the angle. Let's call it theta. So tangent of theta, the opposite side is 366. The adjacent side is 268. So the answer is 54 degrees below the negative x-axis. So for completeness, it's 454 millitesla, 54 degrees below the negative x-axis. That's problem 15.